Okay, radical equations. Before we go into radical equations, I want to talk about this situation. What type of equation is this? What type? What type of equation is it? So, of course. Good, perfect. And I'm going to do something to it that is not necessary. But bear with me for a moment. Let's say I want to square both sides. And if you ask me why, I'm going to say, never do this. I'm just making a point. And you'll see the point in a second. The left-hand side is, and the right-hand side is? Good. What type of equation is this now? Perfect. It is quadratic. Remember, I started with a linear, correct? I squared both sides and I got quadratic. This particular linear equation has how many solutions? One solution, sorry. What about the second one, which is quadratic? How many solutions will the second one have? So here's the point I'm making. One of the solutions from here will not work in the original problem. Right? How will I solve this? I know how. It's a typical situation for which of the four methods? Of course. And what do I get? Because I have to get two solutions. Right. But obviously, which one will not work in the original problem I started with? Of course. So only x equals 2 works. X equals -2 is a byproduct of squaring. It's called, you don't need to remember this, I'm not going to test you on this, but it's called extraneous.
Wouldn't -2 also work?
One sec. Oh, okay. The original problem was x equals 2, not x squared equals 2 squared. So now let's plug in -2. Does it work?
Oh, okay.
Okay, perfect. So the extraneous solution happened or appeared because we squared both sides, and squaring both sides is not 100% legitimate operation. What does that mean? Okay, I choose to square, that's fine. But the new equation may not have the same solutions as the original one. But then why do I square? Because I don't have other methods. Not for this, but for radical equations that we are going to talk about in a minute. Okay? So bottom line is, every time I square, I have to say, when we cube or take to the fifth, the solutions will work, all of them. But every time we take to the second power, the fourth power, the sixth power, and even power, you have to check the solutions. But instead of that, we say, every time we raise to a power, because it's easier to remember, we raise to any power both sides. Not add 5 to both sides, subtract 3 from both sides. That's okay. That's legitimate, 100%. But when we take both sides to a power, solutions that don't belong anywhere may pop up. Okay? So this was an example why some solutions that we get on the second equation may not work in the original problem. But of course, we're not going to square both sides of a linear equation. So here's our first example. Number 12 on the same page, which was 185. So we have the square root of 20 minus x equals x. Now this is a different story. I'm going to ask you what type of equation is it, and you will not say linear, because it's not linear, but what is it?
Quadratic.
It cannot be quadratic if it has a square root on x. Right? So what type of equation is it? Radical. But very good. Okay. So yes, in this situation, I'm going to raise both sides to the third power.
No.
Of course not. Why not the third power? I want to raise both sides to the third power.
Square root.
It's the square root. So if this index is 2, I can only eliminate that radical only if I square. What if I have the cube root? I will have the cube. What if I have the fourth root? And so on and so forth, right? Because a radical is a power. So the square root of 2 is 2 raised to which power?
2.
Obviously, 2 squared cannot equal the square root of 2, right? So the square root of 2 is a power. Which power? Anyone remembers? Over 1 over 2. 1 over 2. What about the fifth root of x squared? Is x to which power? 2 over 5. 2 is the numerator. The index of the radical is always the denominator of that fraction. Good. So now, please tell me the result here on the left-hand side. When you square the square root, what do you get?
20 minus 30.
Good. Excellent. What do you get when you square the right-hand side? Excellent. So although we initially started with what type of equation again? Excellent. This is what it collapsed into. After we squared both sides, we got rid of the radical, but now we have what type of equation? Excellent. How do I solve this one?
Set it equal to 0.
Excellent. I have to. Yes. So I'm going to move negative 8x to the other side, and I'm going to move 20 to the other side. And then you can read it from the left or read it from the right. I just prefer having 0 on the right-hand side, but that's me. It doesn't matter, really. So it's x squared is positive, the negative 8x becomes positive, and the 20 becomes negative. And that's what you see. I have 4 methods. Which of those 4 methods? 2 of those I will not even think about. Which 2 methods? Of course, because it's not set up. And what is the other method that I will not even think of? Of course. So I have 2 methods left in the urn, if you want, pull, or pick one, doesn't matter.
So either
If
factor
factoring-
or
yeah.
quadratic.
Yeah, if factoring takes you like this, do it. If it doesn't take like this, quadratic formula. But it takes like that.
It's going to be kind of positive.
Yes, please. Sorry, I didn't see you.
I just had a question. Since you raised the x,
So x is positive. Is x positive? Is x positive here? Negative 8 move to the other side. Will it become positive 8x? And 20 move to the other side. Will it become negative? I just rearrange them. You move them to the right hand side, and then you just flip the signs. So it's 0 here, negative 20 plus 8x plus x squared. X squared plus 8x minus 20 equals 0.
okay, that's what you can.
Yeah, I understand. Yeah, it's just because it's just a habit. I like to have 0 on this side, but it doesn't matter. You can have 0 on the left. Not important. Good. So you said x plus 10. Somebody said x plus 10, and
Excellent.
good. So we have 2 options. And the options are x equals negative 10 or x equals I have no idea. Maybe. Maybe both work. Maybe just one. Or maybe none. I have no idea. I got 2 solutions, but who knows? I have to go back to the original problem, and this is the original problem. I plug in negative 10. I know it's not going to work. Because the square root is always a positive number. This cannot be negative 10. Unless it has minus in front. If it has minus in front, then it could be negative 10. Okay, let's see. We don't remember that. So negative 8 times negative 10 is Positive 80. Positive 80 plus 20.
22.
The square root of 100.
22.
One more time. The square root of 100.
10.
10. Is that negative 10? No. Good. Now I'm trying 2. Negative 8 times 2.
Negative 16.
Negative 16. Very good. 20 minus 16.
Negative 4.
4. The square root of 4.
2.
That's what we mean by extraneous solutions. Negative 10 was a byproduct. Was a product or a number or a solution coming up from squaring both sides. But has nothing to do with the original problem. It doesn't work. Very good. Other questions here? Other questions? Should we look at another one or we move on? Say it again. Another one. Very good. So let's take a look at 14. And 14, x plus 10 equals x minus 2. Okay, what type of equation is this? It's a radical equation. Good. Is the radical completely isolated? It's completely separated from the rest?
No.
Yes, it is. So the radical is on one side, everything else is on the other. Now, what happens if I have two radicals? I want them to be separated, one on one side and one on the other. What about having three radicals, which is not going to happen in this class? I can separate them. Two will be on one side and one on the other. There's nothing else I can do. I can show you if you encounter problems with two radicals. I think with one radical is good enough. But if you encounter problems with two radicals in the homework, please don't do it. Show it to me first, and I'll show you in class the first problem. Okay. So what do we do?
Square both sides.
Notice that we are not squaring term by term. Do not put a square on the left and the square on x and the square of negative 2. Please not do that. We square the left-hand side as one whole, and we square the right-hand side as one unit. The left-hand side is, now,
Did you write it out twice?
say it again.
You write it out twice or just leave it like that?
No, you
It's
four.
gonna be x squared minus 4x plus 4.
Thank you. You made my day. No, we do not FOIL anymore, please. We want to move forward, not backwards.
Oh, oops.
This is what we studied on the first day of classes. First term squared minus 2 times the first times the second plus the second term squared. Will you lose points if you FOIL? No. Absolutely not. I'm not forcing you to use this method. I'm asking you to move forward with me. That's all I'm asking you. Good. So we started with a radical. It collapsed into a quadratic. Obviously, what do I do next? Yes, I have to move x and I have to move 10. So this is x squared minus 5x minus 6 equals 0. So this was positive x. I moved it here. It became negative 5x.
Oh, okay.
This was positive 10. I moved it here. It became negative 6.
Okay, sorry.
No problem. No problem. Okay, so now we know the drill. This is all done. It's in descending order. 1 is the leading coefficient. What do I do now?
3 and 2.
Yes. So x, no. X minus 6 and x plus 1. So the product is negative 6 and the sum is negative 5. And then we have two options. And the options are and negative 1. Why am I doing all this? What am I trying to trigger your memory? What am I really saying here?
Check.
Yes, exactly. That's what I'm saying. Please check because they may or may not work. Both may work, one may work, or no solutions whatsoever. It's possible that when you plug this back in, both of them, it's not going to work. Both of them are extraneous solutions. It's very possible. So do not plug in this. This is not the original problem. The original problem is here. I'm checking 6. The left-hand side is 4. The right-hand side is? Will you accept 6? Acceptable. Now, I replace x by -1. The left-hand side is? Yes, of course. It's square, it cannot be negative. So the left-hand side is 3. The right-hand side is? 3 does not equal -3. I will say no way. Okay, moving on. Do I still have time? Yes, I have about 12 minutes. Okay. There's another category here of equations, quadratic in form. And you can say, wait a minute, are they quadratic or not? What's this in form? It only means that deep down in their heart, they are quadratic. But actually, they're not quadratic. Okay, so let me give an example. Let's say 42, same page. X to the 4th minus 13x squared plus 36 equals 0. And when I ask you what it is, you're going to say it's polynomial degree 4. What are you talking about here? What's all this? Quadratic in form. What is that? It's polynomial degree 4, right? True. It is polynomial. It has degree 4, which means how many solutions I have to show? 4 solutions. However, I don't really know how to factor this. I don't have 4 terms to factor by grouping either. So there must be a different way if it is at its core or heart quadratic. Okay, or it might be. So the method I'm going to show, it works only if it's quadratic at heart. But if it's not quadratic at heart, the method fails. Okay, so what am I saying here is, I'm looking at x squared, and I'm looking at x to the 4th. Which of these two has lower power? I know it's silly, but I just want you to say it. Right. I'm going to say, give me a letter, anything but x, any letter you want to work with. A, it is good. A is good. I'm going to say let A be x squared. So don't erase anything. I'm making a point. So this will be replaced by A. But I can have x and A in the same equation. I make my life 10 times more difficult. But now let's look at this. Is there anything I could replace that piece by in terms of A? That's it. So if you squared x squared, you get x to the 4th. So if you square this, you get this. So at heart, this equation is quadratic. No, it's not quadratic. It's quadratic in form. Deep down in its core, it's quadratic. It was initially quadratic, and they said, let's replace A by x squared. And they came up with something else. Okay. But this I know how to solve. This will take me 20 seconds or less to figure this one out. And how do you factor this? The quadratic one. Yes, A minus 4 and A minus 9. Excellent. So we have 2 options for A. Can anyone give us the options for A? Good. But now you can say, how do I present the answer? We're not done. A is our baby. We needed this baby to help us solve the equation. But the solution has to be in x. So now I have 2 more equations to solve. A equals 4, which is basically a different equation, and A equals 9, which is basically a different equation. What equation is A equals 4? Please dictate.
squared.
equals, that's it. Because a is x squared. So I go back and replace a by x squared and get 4. And the other equation is
X squared is 9.
exactly. I know how to solve these because there is one specific method that does the job in a blink. Which method am I referring to? Take the square root. Excellent. Well done. How many solutions? Be very careful because if you apply the square root and you write x equals 2, that's wrong.
Plus or minus.
Yes. And then the other one?
Plus or minus 3.
How many solutions did we expect?
4.
Here they are. The solutions are plus or minus 2, plus or minus 3. What did we do? Yes, please.
I don't understand how you got x squared equals 4 and x squared equals 9.
A is x squared. So I replaced it. So what we really did use here for an equation quadratic form, we used a substitution. A substitution was used. We substituted x squared for a. Or we replaced x squared by a. We got a much simpler equation to solve. We solved this in terms of a, but this is our inside protocol if you want. We still have to present the solution in terms of x. We can use a as the final answer. And we also expected 4 solutions anyway, so we got the 4 solutions. Okay, I think we're ready for another. Yes, please, Kayla, go ahead.
So if that was like on like our homework or a test or something, how would they like ask that? Would it be like find
They could say use
A.
a substitution. No, they could say that's a very good question. Thank you very much.
just so like when we're doing it?
Right. Let me show you directly. That's a very good question. Solve each equation in exercises. Solve each equation exercises 41 through 60 by making an appropriate substitution.
Okay.
So that will be your question normally.
So will
But-
it come from like a word problem?
It could, but when you see something like this, it's a very good question, excellent question. Let me put my tent up again. Okay, so it's a perfect question. Here's why. That's why I said, okay, this is an equation. What is it? Polynomial degree 4. What are you talking about? Quadratic in form. But I can't solve it. I don't know how to factor this, right? Other students, when I present this topic, they say, but I can factor without a substitution. That's fine. You can. It's perfect. You could have said from here, okay, I'm going to factor into x squared minus 4 and x squared minus 9. If you see that, perfect. Perfect method. But if you don't see it, it's better to use a substitution, right? And this is possible only because at the core, at its heart, that equation is quadratic. If I change this power 4 into power 3, it doesn't work. And no one can solve that equation by hand. If I change that power 4 into power 3. It's no longer quadratic in form. We cannot do what we just did. Okay, let me show you one more example of this type. Let's look at 56. Any questions? Please always stop me if you have questions. Anyone? Anyone? Any questions? Okay, 56. I'm copying 56 is x plus 3 squared plus 7 times x plus 3 minus 18 equals 0. Okay, so let's look at this equation. Yeah, when I square x plus 3, I will get x squared, and I distribute it, I combine my terms, and I can take it from there. But there is another way that I'd like to practice now. Do you notice anything when you look at this first look? Do you notice anything? Right. So what if I say, okay, let me call this t. So let's say let t be x plus 3. Only if this can be expressed in terms of t. If that piece cannot be expressed in terms of t, the method fails and I have to think of something else. But can I express x plus 3 squared in terms of t? How?
T squared.
Do you all agree with this? Do you all agree that now the equation is t squared plus 7t minus 18 equals 0? The method is useful, but a little bit more sophisticated problems, I would say. But we're fine with this. So can I solve this? Yes. I don't have any problem with that, with this particular quadratic equation. What is it? So t minus, okay, so minus 2 and t plus 9, and then I have two options for t. And what are the options for t? And? Good, but these are two different equations now. What do I write for this? What do I write for that?
X plus 3 equals 2.
Of course, because t is denotes x plus 3. So then I have x plus 3 equals 2, and I'll get x in a second. And then I have x plus 3 equals negative 9, and I will get x in a second. So, oops, sorry, no one can see. Sorry. Okay, so what is x from the first one? What is x from the second one? Very good. That's it.